Okay, so the following questions relate to questions 7, 8, and 9. So that's when we know that's when they do that. That means we can draw on information from the other questions generally. All right, a large population of mutton birds migrate each year to a remote island, nest and breed. There's 4 nesting sites, A, B, and C, D, and researchers suggest that the following transition matrix can be used to predict the number of mutton birds nesting at each of the sites in subsequent years. So they're telling you the states are going to be year to year, and you've got your transition diagram there. All right, so it says in question 7, 2,800 mutton birds will nest at site C in 2008, and then of these 2008 mutton birds, the number of that will nest at site A in 2009. So really what we're saying here is we're going from C. We want to see what happens to C to A. Okay, so we look for that in our you can look in the transition, it's probably the easiest. So from C to A, is 20%. So I want 20, it'll be 20% of the 2,800. Okay, so, and if you want to do 20% of, you just do that. And we end up with 560. Okay. All right, in question 8, the transition matrix predicts that in the long term. So we're talking about long term here. So it will be only nesting. Now we don't have an original state matrix. So what I'm saying, when you don't have an original state matrix, just do a percentage one. So where I say you're going to do the transition. So because this is long term, we want steady state. We'll do the transition to a high power, and I'm just going to do like when we've had the percentage ones before, and I'm just put 100 in the first one, and then it doesn't matter because we're going to the steady state, it will pan that out for us. So you can see I've done that up here, and so if we have a look, here's the transition to a high power, and I just chucked the 100%. So if you see, we can come down here. This number's so little, we might as well say 0, and I'll raise that one to 75. This one's little too, so 0, and this one rounds to 25. So you can look there, we can see that they all end up in B and D in the long term. Okay, so there was a little bit of difficulty with that question, and I assume because there's no state matrix, so kids didn't know what to do. You could have divided, you could have done anything, just put equal amounts in all of them and then see what happens in the long run. But here's a good idea, just to do the percentage, and then you can see it answers a percentage question as well if you need to answer that. All right, so this question 9, sorry, I didn't have enough room on this page, popped it on the next page, but you guys have it there. So let's have a look at this question 9. 6,000 mutton birds nest at site B in 2008. Assume equal number of mutton birds were at 4 of the sites in 2007. The same transition applies, and the total number of birds nested at the island in 2007. So really what we have here is we are linking, we're linking 2008. We're using 2008 and 2007. So if you thought about how do I find 2008, I would do the transition times 2007's option, and then this would give me 2008. Okay, now what they did tell me about 2008 was that there was 6,000 in B. Okay, now we know the transition, we have that from the previous questions, and all we know about 2007 though is that there's equal birds nested at each site. So we don't know what it is. So I might say X amount of birds at each site, because I don't know what that actual number is. But if I know that they're all the same, that means this matrix would have X, X, X down there. If I had A, B, C, D, they'd all be the same. All right, so we've done that. If you have a look, if we tried to solve it in the calculator or something, we can't, because we've got too much missing. We don't know this, we don't know this and this. The calculator won't work it out for us. But with our manual multiplication of matrices, we do know how this number here is calculated. If you think about, this is in row 2 and column 1, that's what this cell is. So if you think about your manual multiplication, you would have taken the row 2 and you would have multiplied it with column 1 to get that answer. So what I actually can set up is I can say 0.35 times x, because this is how we would manually do it, 1 times plus 1 times x plus 0.15 times x plus 0 times x. So I've just done that run and dive down there and written it out, and I know that it equals 6,000. Now, because I only have x's in this equation, and it's only the only thing we don't know, your calculator can do a normal solve for that one. Okay, so I'll do that on the calc and show you. All right, so we ended up working out that x is 4,000. But the question was actually, what was the total number? So you actually have 4,000 at each site. So it'd be 4,000 times the 4 sites, which is 16,000. And that's where we get that answer. So this was a pretty difficult question of the time. So just showing you how you need to know manual multiplication to be able to solve it. Okay, so we're going to work backwards with transitions. So that means we know some of the, we might know a state 3, and they're asking us to go backwards to find state 0. So what I'm going to start saying is, like, this one we have, and this one is the question. So we will say that ends up being the question, and this is the case when they've given us this and they've given us this. Okay, so what you would want to do is you first want to set up a scenario or an equation that you know of how linking these 3 matrices together. So you know, what we do know is we would normally find S3 by we can use the transition to the power of 3 times SO. Okay, so what I'm saying is, so this is what we know, and we've been given this one, and that one's the question. Okay, so we're going to have to rearrange this equation to be able to solve for SO. So I'm just going to, over here, talk about if I had, say, 4 equals 2x. So really, you know that number, and you know that number, and that's the number you don't know. So when you move this 2 over, don't you end up dividing by, you really divide, don't you? It does the opposite for you to be able to solve for x. So what you're going to do is we want to move this t to the power of 3, we want to move it over the equal sign. So it is actually multiplying there, but we want to divide. But if you need to remember, we don't divide in matrices. We use the inverse, or it's died again. All right, so we use the inverse. So we're sort of going to do the same here. So we have to be careful though, because this is pre-multiplying, because it's in front of SO, we'll put it in front of S3 when we move it over. So what we're going to have over here now, the way we're going to solve it, is we're going to do t to the power of -3, because that's how you divide. Use the negative powers times S3, and that will give me the answer to that. Okay, so this is, we know these two, and we've now solved for, sorry, I should have written what that one was. We've solved for SO. Okay, now remember when I said the one that when you're doing the power trick, I said the one you want, so really I want 0. That means that these two numbers should give you what you want. Now, does -3 plus 3 give 0? It does, doesn't it? Yeah? So that means that checking for those to work works here. All right. Then we've got, so that's when you just have this first scenarios, just when you have the transition and the state matrix. When we get into the recurrence formulas down here, so now we're using these recurrence formulas, so it's when we have this little extra bit, the B, you can't go jumping steps. So see how we did to the -3? We won't be able to do that. When you have these extra ones, you have to actually go step by step. So sorry, they've said find S2, and I'm going to say that I forgot to say given that you have, what I'm going to do is say S5. No, actually I won't go that far. I'll go 4. I'll say S4. Okay. All right. So given that we had S4, so I want to go back to S3. All right. So you have to go step by step backwards. So if I want to go back to S4, the first thing I'm going to have to do is find S3. So if you think about it, we'll link S4 and S3 together. Would have been the transition times S3 plus this B. Okay, so if I want to go backwards, what I'm going to have to do is step by step. So first you would have moved this B over. So it would become, you get S4 and you'll minus this matrix B because it's plussing on this side. That would be the first thing you move over. And then we want to divide by so I'll just leave that there. Okay, then I want to move this transition diagram over, which means it wants to divide, so I will times by the inverse. So the way that will be worked out is you will have the transition to the power of -1, and that'll get times by whatever you found out this one to be. But you can step it all out in the calculator like this though, in one go, and that would give you, then you're left with S3. So now you've got S3, you have to do the same process again to go back another step. So I've got to go back again. So if I'm trying to find S2, okay, so I'm still going, S2, we would have to, we'll just use this little formula now that we've set it up. S2 is going to be the transition to the -1 times, and this one you would have found S3 minus B. Okay, so that's how, sorry, that's not a bit unclear that that's 3. Okay, so you got to go step by step. Okay, so that would be a hard question. They never go more than 2 because it takes a while because you've got to go step by step. Okay, so if you were given the recurrence relation, and here's another one where it's minus though, and they said you were given T and S3, find S2. So just link up, first work out how they all link together. So I would have found S3 by doing the transition times S2 minus C. So what the question's saying, you'll see, is that you're given this one, you're given this one, and you're given this one. You don't know. The question one is that one. You don't know that one. So we have to work backwards. So this time I'm going to move this C over first. So be careful with that. That's minusing. So when I bring it over to this side, it will add against that one. And then I will want to divide by T. So I'm actually going to times by the inverse. And because it's at the front of S2, it has to be at the front there. And that will give me S2. All right. Okay. So you've got these written out just to help you. But here's some, I do have some examples. Okay, I'm going to look at question 7 now. A study of the antelope population in a wildlife park was shown that antelope regularly move between 3 locations, east, north, and west. Let AN be the state matrix that shows the population of antelope at each location after n months after the study began. The expected population of antelope in each location can be determined by the matrix recurrence rule. AN plus 1 equals TAN minus D. So you can see, as it says there, it's a recurrence rule because it's using this terminology of how you get the next term using the term before. But we can see it's one of these ones where we have an added matrix into the scenario as well. So we can't use any of the power tricks if we're trying to work out a future state. So we've been given, as you can see in the formula, we need the, we've got the T matrix, we need D, which is given, and they've given us A3. So this is after 3 months or whatever. So it says the number of antelope in the west location after 2 months. So that's A2. So we're after A2, but we've been given A3. So what we're going to do is we're going to set up a rule showing how we got A3 using A2. So A3 would have been found by going the transition times A2 minus D. So into, so like what we were saying before, we've been given this one, we have this one, and we have this one, and this A2 is pretty much the question. This is the one we need to know. So we're going to rearrange the equation so that A2 is the one that we find. So the first thing we'd move is the D. So over here we would be doing the opposite, which is adding D. Okay, and then the next thing we would do is, because this, we want to move this T over. Now it's timesing, so it'll divide, but we don't divide, we multiply by the inverse. And because it's at the front, I'm putting it at the front here. So essentially we are left with A2. We've got a formula now for A2. So this is what we will type into the calculator. Okay, so I've popped this in the calculator so you can see here's that transition to the negative power. And here we've got A3 plus the D, because that was the reverse. Now just take note, I've got this in brackets, so I've done exactly like I wrote out in the calculator. And here's the answers. So we've got east, north and west, and they wanted to know what was in the west at A2, because this is A2. So west is 227, and there's our answer. All right, let's move on to this other question. In question 8, it says an airline parks all of its planes at Sydney and at Melbourne Airport overnight. The transition diagram shows the change of location from night to night. Now, here was a very important statement where they say there's always M planes at Melbourne Airport and S planes at Sydney Airport. So the amount of planes at an airport, each airport, don't change, so they balance out. So because of the planes parked on Melbourne Airport Tuesday night, 12 had been parked Sydney on Monday night. So that's essentially showing us what has happened if we were at Sydney Monday and, had been a Monday and then went to Melbourne. So we've got 12 going out. Now, because of the blue statement, like they have to remain the same. If you've got 12 going out, 12 must be going in, and so I've done that in the green. Okay, so really you do know, so how are we going to work this out? We do know we can make a statement. So say if I was talking about, we know that 0.48, or that's 48% of the Sydney planes equals 12. So you could change that to 0.48 times S equals 12, and you can do solve if you like. If you're not very good at solving the equations, just go solve, comma S, and you work out what Sydney is. Okay, so you end up with Sydney being 25, and then you can do the same thing with the green, except you'd say 0.2 of Melbourne's equals 12, and then you can change that and solve, and you'll end up that Melbourne equals 60. So you had to add them together. They said how many planes does the airplane have, so that would be the 60 plus the 25, and that's how we got 85. So we need to be careful and read all the facts that they're telling us. That's the only way we could have worked that out.